In this video, we were going to build a complete web app that can tell you whether a piece of text was written by a human or generated by AI. The app we are looking at takes any input, an essay, a paragraph, or a single sentence, and instantly tells you if it is AI generated or human written. But we are not just showing the app, we will go through the entire process step by step, from loading and cleaning the dataset to training a machine learning model, and finally deploying it as an interactive web app using Streamlit. Let's get started. First, head over to kaggle.com and make sure you are logged into your account. Then click on the Datasets tab in the sidebar. In the search bar, type AI generated text dataset. Once you are on the dataset page, click the download button. This will give you a .zip file containing the dataset. Make sure to unzip the folder before moving to the next step. Once you have downloaded and unzipped the dataset, head over to Google Colab. We will use it for our initial data analysis and model training. Colab is free, cloud-based notebook environment that runs in your browser. Perfect for working with dataset like this. First, open a new notebook. Then on the left sidebar, click the folder icon and choose Upload to upload the CSV file into your workspace. Once the upload is complete, we were ready to load and inspect the data. The original file name had spaces, so I replaced spaces with underscores for easier accessing code. So let's start by importing the libraries. Import pandas as PD for data handling and import numpy as NP for numerical operations. Now let's create a df variable. We will load the dataset using pd.read_csv function and then display the first few rows using .head function. After running df.head function, we can see the dataset has two main columns: text, which contains the actual essay or sentence, and generated, which is the label telling us who wrote it. A value of 1 means the text was generated by AI, while 0 means it was written by a human. Next, let's check the structure of our dataset using tf.info function. This shows the number of entries, column names, data types, and help us see if there are any missing values. From this output, we can confirm that there are no null values and both text and generated column are present with valid data types. Let's now check how many AI-generated text and human-written text we have in the dataset. We will use value_counts function on the generated column. From the output, we can clearly see that the dataset is highly imbalanced. We have 1375 human-written text labeled as 0 and only 85 AI-generated text labeled as 1. This imbalance could affect the model performance. So later on, we will consider techniques like resampling or class weight during training. Now let's visualize the label distribution using Seaborn and Matplotlib. First, we import matplotlib.pyplot as PLT. It's a core plotting library in Python for customizing charts. We also import Seaborn as SNS, which is built on top of Matplotlib and makes it easier to create clean, stylish plots. Here, we use sns.countplot function to create a bar chart. We pass x equal to generated to plot the frequency of each label in the generated column, and data equal to df tells it which data frame we are working with. Then we add a little title to the chart so viewers instantly understand what they were looking at. Next, we label the x-axis as generated label and the y-axis as count to clearly show what the bars and numbers represent. Finally, plt.show function displays the plot inside the notebook. From the output, we can see the dataset is imbalanced. There are 1375 human-written text and only 85 AI-generated ones. The chart clearly shows this. The left bar is much taller. We will handle this imbalance later during training using resampling or class weights. Now let's split our features and labels. We will store the text column in X and the target column, whether it's AI generated or not, in Y. Let's start by importing all the tools we need for text preprocessing. We use RE for cleaning text using regular expression, and string to handle punctuation marks. Then we import NLTK, a popular toolkit for natural language processing. Now let's download the NLTK resource we will need. Stop words. These are common filler words like they, is, are, and you. They usually don't add much meaning, so we remove them to focus on the important words. Puncti. This helps split full sentence into individual words. This process is called tokenization. WordNet and OMW 1.4, these are used for lemmatization, reducing words to their root form. So words like running, ran, and runs all become run. Now that we have downloaded everything, it's time to bring in our NLTK tools. We import stop words to remove unnecessary words like they and is. Then word underscore tokenize helps us split the text into individual words. And finally, WordNet Lemmatizer simplifies each word to its root form. For example, turning running into run. These are essential steps to clean and prepare our text before it goes to the machine learning model. Let's first create an object called Lemmatizer using WordNet Lemmatizer. This tool helps reduce words to their base form. For example, running becomes run, which simplifies our text and makes it easier for the model to learn patterns. Let's define a function called clean underscore text that will handle all the pre-processing for our text. This function takes in one piece of text at a time and performs a series of cleaning steps. We begin by converting the input into lowercase, but before that, we make sure it's treated as a string. That's important because in our dataset, the text column is stored as type object, which is how pandas represent string data. Converting to lowercase helps us treat words like uppercase AI and lowercase ai as the same. Next, we remove any links or URLs from the text using regular expressions. These links don't really add meanings to the message and could confuse the model. Then we strip out all the functions like commas, periods, and question marks using Python's built-in string library. If there are any numbers or digits in the sentence, we remove those too. In most cases, they aren't helpful for our classification task. Now, we break the sentence down into individual words using a process called tokenization. This is done using NLTK's word underscore tokenize. We split the text by spaces and punctuation to give us a list of words. After that, we load up a list of stop words. These are common words like is, they, a, and in that don't carry much meaning. We want to remove them to help the model focus on the important words. Then, for each word in our list, we check is it a stop word? If yes, we skip it. If not, we pass it through the lemmatizer to convert it to its root form. All of this is done efficiently using a list comprehension, a neat Python trick for handling multiple steps in one line. Finally, once our words are cleaned and simplified, we join them back together into a single string. That's the clean, final version of the text ready to be used in training our machine learning model. Now we apply the clean underscore text function to our entire feature column X using apply function. This means we were going to clean each row of text in our dataset using the function we just defined. Think of the apply function like this. It runs our clean underscore text function on every single row in the column. So instead of looping through each text manually, apply function does the job for us cleanly and efficiently. Behind the scene, it's just applying the same logic, lowercase conversion, removing URLs, punctuation, numbers, stop words, and lemmatization to every message one by one. In short, clean, simplified, and ready for machine learning. Let's quickly compare the original and cleaned text. We create a new data frame with two columns, the raw input and the processed version. To make sure long text don't get cut off, we set display.max underscore call width to none. Then we display the first 5 rows, and you can clearly see how much cleaner and more consistent the text looks after pre-processing. Now, let's bring the TF-IDF vectorizer from sklearn.feature_extraction.text. This tool helps us turn text into numerical values using a method called TF-IDF, short for term frequency inverse document frequency. It measures how important a word is in a sentence compared to the whole dataset. Next, we initialize the vectorizer and transform our cleaned text into numeric format. Here's fit_transform first learns the vocabulary from all the text, then it transforms each sentence into a vector of numbers based on word importance. This step is essential. Now the text is ready for model training. When we type X, we get compressed sparse row sparse matrix of E-type float 64. This means our dataset has 1460 rows, one for each text entry, and 17633 columns, one for each unique word or feature found by the vectorizer. Out of all those possible word positions, only 331,607 have actual values. The rest are zeros. Because most values are zero, it's stored in a compressed sparse row format. This saves memory and makes processing faster. So basically, this is a numerical version of our text ready for machine learning. Now it's time to split our data into training and testing set. We use train test split from sklearn.model selection to do this. Here's what each part means. X is our features, the vectorized text. Y is our labels, 0 for humans, 1 for AI. Test size equal to 0.20 means we were using 20% of the data for testing and the remaining 80% for training. A random state equal to 42 ensures that the split is consistency. We will get the same result each time we run it. This gives us 4 new sets: X train, Y train used to train the model, X test, Y test used to evaluate how well the model performs. Okay, let's create our model using logistic regression from sklearn.linear model. This line imports the logistic regression model, a solid choice for binary classification tasks like this one, where we want to separate human written from AI generated text. Now let's create the model. We're creating an instance of the model. Setting class weight equal to balance is super important because our dataset is imbalanced. We have way more human written samples than AI ones. This tells the model to pay extra attention to the underrepresented class label 1, the AI text. And finally, we train the model. This is the learning phase. The model looks at the training data and learns patterns that helps it tells the difference between AI generated and human written text. Now it's time to make predictions. I created a variable yprint and used model.prediction method inside xtest. This gives us a list of results showing whether each text is human or AI based on what the model has learned. Let's check how well our model is performing. We use classification report from sklearn.metrics. This gives us detailed results like precision, recall, and FN score. For both classes, human written and AI generated, and from the output, our model is doing great with 99% accuracy overall. Now, let's double check how stable our model is by using cross validation. We use cross validation score to test the model on 5 different splits of the data. The score is set to FN macro, which gives equal by to both classes, and the result we get an average FN score of around 0.94, which means our model is performing well consistently across different parts of the data. Let's break down how well our model actually performed. Using a confusion matrix, each box here shows the number of predictions made in each category. Top left shows 270 correctly predicted human text. The bottom right 19 correctly predicted AI text. The half diagonal just a few mistakes. 2 AI texts were mistaken as human and 1 human as AI. That's pretty solid performance, showing our model is doing a great job at telling the difference. Alright, now that our model is trained, let's save it for future use. We use Joblib to save both our trained model and the TF-IDF vectorizer. This way, we don't have to retrain everything from scratch. We can just load the pickle files and start predicting right away. Alright, now that we have trained and saved our machine learning model, it's time to build a simple web app using Streamlit. Let's head over to Visual Studio Code or whatever code editor you prefer and start creating our app. We will use Streamlit to make everything interactive, clean, and easy to use, even if someone has zero coding knowledge. So open up VS Code, create a new Python file. You can call it app.py, and let's get started by importing the necessary libraries. Let's quickly install everything we need for our Streamlit app, including Streamlit itself, Joblib to load the model, and NLTK for text cleaning. Just run this single command in your terminal. Alright, let's get started building our Streamlit app. First, we import Streamlit, which is the main library for building web apps in Python. Super simple and interactive. Then we bring in Joblib. This is the tool we use to save and load our trained machine learning model and TF-IDF vectorizer. You can think of this like setting the stage. Streamlit handles the UI and Joblib brings back our trained brain, the model, and the vectorizer, so we can use them in real time. Alright, now head over to your Colab notebook where we wrote all our pre-processing code, including the clean underscore text function, the word net lematizer, and the necessary NLTK inputs. Just copy those lines and paste them right here in your Streamlit app, just below the Joblib imports. This way, your app can pre-process any new text exactly the same way we clean the training data. Okay, now let's bring back the two important things we build in Colab, our model and the vectorizer. The first one is our trained model. It knows how to tell human and AI text apart. The second one, TF-IDF vectorizer, helps convert any new text into the format the model understands. Basically, this gets our Streamlit app ready to make predictions. Now, let's design the app's interface. We will start by giving it a title and a subheading so users know exactly what this app does. This tells Streamlit to display a bold title and a smaller description just below it. Super simple, super clean. Alright, now let's add a simple text box where users can paste their essay or paragraph. This will show a clean input area in the app, perfect for dropping in any text you want to check. Now we add a button that runs the prediction when clicked. This creates a button labeled classify. Once a user clicks it, we will check if they actually typed something in. If the box is empty, we show a warning message, no empty submission allowed. Now, if the user has entered something, we clean and vectorize the input before making a prediction. First, we pass the user's text through the same clean underscore text function we used while training. This ensures consistency. Then we transform it into a numerical format using the TF-IDF vectorizer we previously saved. Next, we use our trained model to make a prediction. This line runs the model and gives us a prediction either 0 or 1. Finally, we display the result in a friendly way. So depending on the prediction, we show a green success box if it is human present or a red alert if it looks AI generated. Alright, the coding is done, the model is trained, and our Streamlit UI is ready. Now it's time to bring it all to life. Open your terminal or VS Code terminal and run this command, Streamlit run app.py. This launches your app in the browser just like that. You will see a clean interface where you can paste any essay or paragraph, click classify, and instantly see whether the text is likely written by a human or AI. Let's start by testing with the first text, the one about rainbows. I will paste it, click classify, and boom, we get this text appears to be AI generated. That's exactly what we expected. It's a short, factual, and lacks of personal tone. Classic AI waves. Now, let's try the second one. The letter about Electoral College. Pasting it, hit classify, and we get this text looks like it was written by a human. Nice, the model picked up on the opinionated style, the emotion, and the structure. This is very much human written. And that's it. Our AI essay detector is doing its job. It can tell the difference between a human and an AI written paragraph pretty accurately. Now it's your turn. Paste it in your own text and see what happens. If you found this helpful, don't forget to like, share, and subscribe to Self Learning for more hands on machine learning and AI projects. Drop a comment below if you have any question. I will see you in the next one.